The power of this all-terrain vehicle's engine can pop the wheels right off. But the Thundercat is built for takeoffs and hard landings. Soak, wash, and dry. This new style car wash babies your ride and your paint job on less than 10 liters of water. Most of us have seen elevators free fall in the movies. But what if the cable snapped on the one you're riding? The ATM checks your ID, calls your bank, and hands over the cash. Let's take the lid off these machines and see how they work. What keeps all-terrain vehicles, or ATVs, really popular is the way they power through axle-busting trails in one piece. How do you prevent the machine from flipping, falling apart, or flying off the trail? By matching its engine's power with the durability of its components, like the axle, suspension, and tires. This Thundercat H2 looks and sounds like every other ATV out there. But it's pushing the limits with one of the most powerful engines on any production ATV ever built. And to keep the machine from breaking apart under its own power, Thundercat designers had to rethink every other component and how the engine sends power to the wheels. Let's see how it works. When you're negotiating rocks and ruts, it's all about torque, the strength of the wheel's rotation. The more you've got, the better. And the power for it starts with the Thundercat's engine. 950 cc's certainly sounds big, but this power plant is not just about size. Its cylinder heads look like a baseball cut in half. This hemispheric design allows more air and fuel into the combustion chamber, and the shape of the valves help move this potent mixture in and out fast. That buys you low-end torque, so you don't have to gun the engine to do this. Power under control. It's what you need to negotiate steep inclines and maintain traction going through water and mud. The key is to give the wheels power without spinning them out, even at triple the torque of other stock machines. When you gun the engine, you get variable speeds on the wheels with a full range of control, from a slow crawl to a blast-off launch. How does the Thundercat do it? For that kind of control, the transmission needed a rethink. Mechanical transmissions only allow a few different gears to choose from, which means when you change them under load, the wheels get hammered with a jolt of power on every shift. Instead of installing a heavy, cumbersome gearbox, Thundercat designers installed a continuous variable transmission, CVT for short. A drive belt sits in a V-groove on a wheel connected to the engine. As the engine revs, centrifugal force drives an inner wheel in the V-groove to the center, forcing the belt higher towards the edge of the wheel. At high revs, it's like a larger or higher gear. At low revs, a small or low gear. Totally variable. So the Thundercat can power up these rocks at a crawl and kick it into high gear on demand without bucking, slipping, or spinning out. ATVers aren't really ATVing unless they get airborne. But when fast-spinning, high-powered wheels hit the ground, the sudden spike in traction and torque could do serious damage to the drive shaft and axles. So they installed a spike load dampener. a clutch system that cuts off the connection between the engine and axle on harsh landings. Once the engine revs down, the axle is re-engaged and power is restored to the wheels, sparing you a broken ride and a long walk home. To make sure this machine keeps a straight line when blasting through water or mud, a limited slip differential helps all four wheels adjust quickly to keep it moving and on the trail. It's easy to see when skidding or turning corners. The outside wheels actually spin faster than the inside ones to compensate for the extra distance they have to travel. Even with limited slip, a wheel that loses contact with the ground spins wildly and cuts torque off from the other one. Now you're stuck. But on this machine, the rider flicks a switch to lock the differential between the wheels so that they spin together. This gives the wheel on the ground or in the mud all the torque it needs to get in and out of trouble. Finally, how do you design a suspension system to keep the frame intact and the rider upright? Start with one of the strongest suspensions ever put into a production ATV and lose the sway bar. Most ATVs use a solid bar to link the rear shocks. It prevents one set from dipping too low on turns, a rollover hazard. But Thundercat's builders didn't want the loss of control that comes with a sway bar. So it got thrown out in favor of fully independent suspension. This allows one wheel to ride high over a rock without pulling the other one off the ground. Without a sway bar, Thundercat turns are kept stable in two ways. First, a AA suspension stops the wheel from riding up on its edge, even during a harsh turn. And stiff steel mesh lining on the tires minimizes body roll. Pretty much as stable as a sway bar, and a lot more fun. A machine like this couldn't do what it does without breaking a few ATV rules. Sure, it gets the machine into trouble, but only the good kind. It takes about 300 liters of water to wash your car at home. The average automatic car wash uses about 150. But the latest tunnel car washes are able to get the job done with less than 10. Not only does this new style wash recycle almost all the water it uses, it's also got the latest gear to protect your paint job. Let's see how it works. The tunnel car wash is a familiar machine. Spray nozzles soak, soap, and rinse. Fabric brushes do the scrubbing. Hot air dries the surface. But they have a few sticky problems that are tough to beat. Scuffed wheel rims from metal guide rails, swirl marks from dirty brushes, and water spots from the rinse job. The designers of this car wash wanted to beat all three of these challenges and save water in the process. It all starts here, where cars line up for the conveyor. The synthetic yellow guide rail sets up the front tires without leaving a mark or scratching the rims. They're made with ultra-high weight molecular plastic. It's got extra long molecules that weave together like a pile of spaghetti. With no open ends for anything to stick to, you get a slick, scuff-free glide like riding on a greased rail. Once on the belt, a sensor tells these rollers to pop up and push the car's back tire. Now it's time to start cleaning. And that's about more than shine. The dirt on a car actually increases aerodynamic drag and lowers fuel efficiency. To get rid of it in a way that doesn't damage your car is the goal of every wash. If a fabric brush picks up and holds onto dirt, it will grind it into paint surfaces. So this pre-rinse is designed to attack the dirt from every angle. A computerized timing system and a stream of compressed air controls the nozzles. The brains and lungs of this machine live in a back room, and it drives almost everything with air or hydraulic pressure, not with electricity. It's cheaper to run that way and a lot safer than mixing electricity with water. Even after the first layer of dirt is rinsed off, there's still a thin layer of hard-to-see stuff sticking to the paint. You need scrubbing power to get rid of that. And even dirt as fine as powder can scratch. Cloth brushes on the spinning wraparound system take care of vertical upper surfaces, while dangling cloth washers, called mitters, sweep up the gaps. The trick to avoiding scratches lies in the fabric. This fuzzy polyester can't absorb anything, so there's nothing that can scratch your paint. But it does trap suds between its fibers long enough to drop it on the car and wipe it away. Next, the spinning heads kick in for the car's lower panels. These ride close to the road and pick up a lot of grime that, if not handled properly, will scratch your car. Old-style spinners had hard bristles, lots of friction, lots of cleaning power, but because they absorbed dirt, they did lots of damage to paint. So today's tunnel washes use a soft foam material. These closed-cell brushes resist water absorption and the dirt that comes along with it. Like the mitters, no dirt means no chance of scratching. Down here at tire level, dirt particles are at their heaviest, so the wash needs tough bristles to get them clean. The ones here are pre-worn and only ever touch the tires. It's called a poodle brush. In a lot of car washes, you'd be hitting the dryers at this point. But this machine is about to attack performance-robbing dirt that gets trapped in cars' cooling systems and brakes. Dirt and bugs trapped in the grill can affect engine cooling. So these brushes give it a second wash. They spin opposite to each other to avoid damaging license plates. Then, some clever engineering attacks dust behind your tire's rims. It's called a pendulum washer. When the front tire hits this bar, it carries spinning washes along with it, blasting the hubcap and brakes clean without messing up your rims. The bar slips into this recessed area, then pops out to the back wheels to start again, just like a swinging pendulum. Momentum helps out with the final cleaning step. A small nudge from your car pushes up one last brush before the final rinse, where a soft rain shower takes off all the soap. By design, falling droplets land gently and roll away. And that means no water spots from splashing like you get in a regular wash. Finally, after 90 seconds of pounding action, it's time to get dry. These fans hit your car with intense air pressure. When ready, they slam open to blow off the water, which doesn't go to waste. Your car may be done, but this machine has one more job to do. Take care of that water. Almost all the used water flows through these grates into underground tanks. First, the dirt is filtered out. Then the water is sanitized before returning to the main storage tank. Up to 80% of the water is reused. This tunnel car wash has put a new spin on an old idea by delivering a near-perfect clean while keeping cars and their drivers' reputations intact. No city skyline would reach these heights if it weren't for this machine. Before the elevator, buildings rarely grew over 5 stories. They perform billions of rides every day around the world. Among the safest ways to travel, there's less than 1 chance in 12 million that something will go wrong with the elevator you're riding in. Let's see how they work. The most popular elevator design is the roped elevator, where a car is raised and lowered by steel cables. The machine's muscle lives up here at the top of the elevator shaft. Its ropes attach to the car and loop around a sheave, a pulley with grooves to grip the ropes that's connected to an electric motor. Turn the motor one way, the elevator car goes up. When the motor turns the other way, it goes down. A counterweight lives on the other end of the ropes to offset the weight of the car. It's usually about half the weight of a fully loaded passenger elevator. So, on an average ride, the two are perfectly balanced. All the motor needs to do to move the car is provide a nudge to tip the balance one way or the other. This system saves energy as well as wear and tear on moving parts. Once the car is moving, the motor's only job is to control one of the two falling objects. Both the car and counterweight are attached to guide rails inside the shaft. They keep everything from swaying back and forth and also give a backup set of brakes something to grab onto. If anything goes wrong with the motor, hydraulic fluid is cut off, and that automatically releases this brake that seizes the ropes for a quick stop. Technically, one of these steel ropes is enough to hold up both the car and the counterweight. The rest are there for backup, in case one snaps. But what if the whole set is cut? Don't worry, it still won't plummet. This machine has a built-in failsafe. There's a governor located beside the motor, with its own pulley and separate cable attached to the car. There are 2 spring-loaded metal hooks called flyweights inside the governor. If a car free falls and the governor spins too fast, centrifugal force pushes the hooks out. They seize ratchets on the fixed inner rim and stop the pulley. The governor's rope jerks on an arm on top of the car, and this locks the brakes. Okay, that takes care of safety. Why do we have to wait so long for it? Call buttons send signals to the elevator's computer. It keeps track of every car in every shaft through sensors on the shaft wall, then calculates which car stops where and when. It's a lot to keep track of. Newer systems can sense a full elevator car. If it's too heavy, it'll skip your floor and come back when it's ready. The idea of the rope elevator is simple enough. One side goes up, the other goes down. It just took a couple of thousand years to figure out how to stop it. It's easy enough to drive, but without brakes, we'd rather walk. If one machine defines our self-serve culture, it's this. The very first ATM opened in New York City in 1939. But it's only in the last 20 years that it's taken over. And it's got a lot of names. Automated teller, banking machine, cash point, or simply a money machine. The one we're looking at is an automatic teller machine, or ATM. And like the bank teller humans it replaces, the ATM identifies you, knows your limits, and provides access to financial transactions. It's also pretty much impregnable. Let's see how it works. ATMs face several challenges. First, make sure you and your card are legit. Second, find your account information. Third, accurately complete the transaction you want. And finally, do it all while protecting an onboard vault that stores thousands. The machine starts by checking your credentials. This black stripe looks solid, but the ATM has 2 readers that see what you don't. 1 million tiny magnets, each with a positive or negative charge. A binary code. The first reader looks for a special code that confirms the card is real. The second reader grabs your account number and password to check against what you've just keyed in. Once your password is confirmed, the ATM connects to your bank's network, and it gives the machine its marching orders and remotely controls access to the onboard vault. Trays in the vault hold different denominations, with up to 1,000 bills in each. One tray is left empty for deposits. When you drop in a check or money with an envelope, it goes into a bin and is manually sorted later. Some ATMs, like this one, can take deposits without an envelope. It's able to hand count bills. This also allows the machine to refill itself. For withdrawals, vacuum-driven suction cups grab one bill at a time and feed it out through a roller system. Delivering bills one by one from the vault keeps you from getting overpaid. This machine is a very careful counter. As each bill squeezes through these rollers, sensors calculate the width of the paper, about the thickness of a coat of paint. Any thicker, the machine figures that 2 or more bills are stuck together. Any thinner, the bill's worn or fake. Either way, the sensors catch it, and the bills get sent to a reject bin. That's likely what's happening when you hear a pause in the machine's counting. The dispenser slot hands over your cash. Your bank's computer records the deal and then tells the machine to return your card and give you a receipt if you want one. Safe and secure. With more than 1.5 million ATMs around the world, most of us simply take our access to cash for granted. And crooks know it. Thugs go after them with blowtorches, crowbars, and trucks. But they don't stand a chance against this machine. Built from over 100 kilograms of steel, able to withstand 22 tons of blunt force, the vault can survive assault more than long enough for police to arrive. And even if they get into the machine, the money's useless. Exploding canisters of dye ruin the cash as soon as the vault's seals are broken. There's also onboard GPS to track the geniuses who try to haul them away. Brainier crooks use an electronic sleight of hand. One technique is to insert a false card reader or skimmer into the card slot and stick a tiny spy camera over the keypad to steal your password. Foiling them is as simple as protecting the number you enter. It took a long time for automatic tellers to evolve into the trusted machine it is today. And until we stop using cash altogether, this intelligent dispenser will continue to take our orders and track them with amazing accuracy.